Welcome to Prescription for Justice. My name is Martin Donohue. In our last episode, we talked about global warming. If you have missed that episode, I encourage you to watch it, which you can do online via YouTube, or you can listen to it as a podcast through KBOO Radio. You can also find it through the Public Health and Social Justice website, where you'll also find at least 200 open access PowerPoint presentations, a number of articles, links to over 1,000 organizations, and a variety of social justice related topics that will be covered. Today, however, we're going to delve into a subset of the problem of climate change, and I'm very pleased to have as my guest Dr. Christina Dahl. Dr. Dahl is a senior climate scientist for the Climate and Energy Program at the Union of Concerned Scientists. She earned her PhD in paleoclimate from MIT Woods Hole Oceanographic Institution's joint program. Prior to joining the UCS, Dr. Dahl was the associate director of a school-wide climate change initiative at Rutgers University and worked on the American Museum of Natural History's Seminars on Science program, a set of online courses geared toward K-12 educators. She also served as a science communicator for Al Gore's Climate Project. Dr. Dahl served as the lead author on UCS's recent report, Killer Heat in the United States. Today, Dr. Dahl, I am delighted to have you with me.
It's a pleasure to be here.
Before we start talking about our specific topic today, tell me what the Union of Concerned Scientists does.
I'd be happy to. So the Union of Concerned Scientists is a national advocacy organization that aims to put rigorous science to work to solve some of the world's most pressing problems. So we work on a range of different issues. I'm in the Climate and Energy Program, but we have a program on food and environment that aims to make sure we have healthy soils so that our food can be healthy, and so that our farm workers can be healthy. We also have programs on nuclear weapons and a Center for Science and Democracy that helps to ensure that science is being put to use when public policy is being made. So they've been very busy in monitoring what's going on at the federal level these days and cataloging any attacks on science that are occurring. So we're an organization that started out of MIT in the late 1960s. And since that time, we've stuck to our roots of doing independent science. And what that means is that we don't take any funding from the government or from industry. 80% of our work is funded by member donations. So anyone can become a member of UCS. You can go to our website, ucsusa.org, and you'll find membership information there. We also have a network of more than 20,000 scientists throughout the world. This is our science network, and we draw on our science network for helping us to do things like draft letters to the editor for local papers, or beefing up our knowledge of scientific topics that scientists like me who are on staff may or may not have expertise in. So it's a wonderful organization. I encourage you all to check it out online.
And I will echo that sentiment. I'll tell you, I've used their reports, which come out on a very regular basis on all those topics. I've used them in my academic work, and they're also eminently readable for the layperson. I would say anyone with really a high school education up could get quite a lot out of them. And such a critical group to have at this time when science is being attacked on all sides and there's a lot of misinformation out there. UCS is shining a light in the darkness. I'd like to start with the basics. Christy, okay to call you Christy for the show?
That's fine, yes.
I'd like you to give our viewers in a few minutes just an overview of climate change and global warming, how we know it's happening, what's the evidence, and maybe just a little bit also of the science of how it works.
Sure. So our climate varies naturally on Earth. It's going to be, some years are going to be warmer than others, some years will be cooler, some places will be wetter, others will be drier. So there's all this natural variability in Earth's climate system. One thing that helps to determine the climate that we have is what our atmosphere is composed of, basically what our air is made of. So our air contains many different gases, including the oxygen we breathe, but also what we call greenhouse gases. So these are gases like carbon dioxide and methane that have the ability to trap heat. So what happens on Earth is that the sun shines down on Earth and we get some of that warmth and that radiation. That radiation is then absorbed by the Earth and then re-radiated back out to space. And it's that re-radiated heat that comes from the Earth that gets trapped by these greenhouse gases in our atmosphere. And it's actually really important that we have those gases in our atmosphere, because without them, the Earth would be a very cold and unlivable place. The problem is that humans have been adding greenhouse gases to the atmosphere, primarily through the burning of fossil fuels. So those are things like oil and coal and gas that contain a large amount of carbon. When we burn those gases, we release more carbon dioxide to the atmosphere, and that makes the atmosphere more effective at trapping that heat. So climate change refers to this process of the Earth warming up in general in response to our atmospheric carbon dioxide concentrations changing. But climate change is much more than just warming. There are all sorts of things that happen alongside that. So many people ask, why did it used to be called global warming and now it's climate change? Well, the warming is one of the primary effects that we see, but that plays out in a lot of ways that we don't see as warming. For instance, we see more extreme precipitation, so heavier downpours is an effect of climate change. We see sea level rising, which is an effect of climate change. And all of that relates back to the fact that we have more carbon dioxide in our atmosphere, but it's not strictly warming. So we encompass all of that within the umbrella term of climate change. The question of how we know it's happening is a really interesting one. Because we have a lot of variability from year to year on Earth, it takes a long time to see the trend of climate change happening. Overall, we've seen about 1 degree Celsius of warming since the Industrial Revolution, which was around 1850 to 1900. And we're able to detect that warming now because it's starting to exceed the natural variations that we see from year to year. There are other things that can cause changes in our climate. We know that changes in the shape of Earth's orbit over very long timescales, thousands of years, are able to drive things like the formation of larger ice sheets and the development of ice ages. Variations in solar activity can cause some changes in climate. Volcanoes can change our climate, but none of those things can explain the sorts of trends that we've observed over the last 100 years or so. Really, the only explanation for the trends we've seen is the increase in greenhouse gases in our atmosphere.
And how do we know how much greenhouse gas was in the environment, what the temperature is? For instance, the thermometers in 1900 may not be the same as the thermometers that we have today. And can we go back in time to really know what the temperature was that long ago?
We can do our best. So there have been direct measurements of the amount of carbon dioxide in the atmosphere since about the 1950s. And that's a continuous record that shows a steady increase over that time. But before then, we have these, we call them paleoclimate archives. So these are natural things that occur in our environment that allow us to reconstruct what our atmosphere or what our temperature was like in the past. So one of those is ice cores. So glaciers and ice sheets are very long-lived, and you can take a core through the ice, and in that core, you'll see tiny bubbles that have been trapped in the ice for thousands of years. And you can measure the carbon dioxide concentration in those bubbles to find out what the concentration of carbon dioxide was when that ice formed thousands of years ago. So based on those ice core records, and there are many other geological types of records as well, we can see that the amount of carbon dioxide in the atmosphere have varied substantially over the past million years or so, primarily in response to the waxing and waning of ice ages, but it had never exceeded a certain value, right? What we see now is concentrations of carbon dioxide that are far above what's been observed in any of those geologic records for nearly 1 million years.
And I think it's important to note that prior shifts in the climate took place over tens of thousands to millions of years, never with the rapidity that we see today.
That's right. The pace of the increase that we're seeing today is far above the pace of even the most rapid climate transitions that we've observed in paleoclimate records.
It's amazing. Really, you're an archaeologist of the climate, and the science is excellent on this, and there really is no question among scientists that this is happening.
That's right. That's right.
So one of the consequences of climate change is that you see in positive feedback loops. In biology, we're used to having negative feedback loops, for instance, with hormone systems and the way cells operate to kind of keep things in check so that growth doesn't get out of hand, which it does occasionally in the case of cancer. But in some sense, global warming is like the cancer of the environment. Tell me a little bit about those positive feedback loops.
Sure. So one of the best known feedback loops that we have is something called Arctic amplification. So when the sunlight shines down on the Arctic ice cap, because that ice is very light in color, a lot of it gets reflected back to space. So that's the same as if, I remember when I was a kid and we would go to a pool in the summertime. We'd come out of the pool in the late afternoon. It'd be very hot out. And to get to our car, we'd always try to walk on the little white lines in between the parking spaces because they were cooler, right? That's because more of that energy is getting reflected back. So as we warm up the Earth, more and more of that ice is melting, and it's exposing the dark, relatively dark ocean waters around the ice cap. So what that means is that more of that sun's energy gets absorbed by the Arctic because we are exposing this dark Arctic Ocean. In turn, that creates more warming in the ocean that then causes the ice to melt even more. So you get this positive feedback between warming and the loss of Arctic ice. And that has implications for the whole globe, not just the Arctic.
And we see this elsewhere in the solar system, not through the use of fossil fuels, of course, but on the planet Venus, where there's basically been a runaway greenhouse effect. And we know this from our astronomers, plus we've sent spacecraft there which burn up within a couple of hours. And that's basically an uninhabitable hellscape because of its greenhouse effect. So your particular areas of interest and your recent report is on weather extremes and killer heat. How does that work, and how does that relate to climate change?
Sure. So as we warm up the Earth on average, there's a greater likelihood of having extreme heat events. So, let's say in the past you'd experienced maybe 5 days in an average summer when the temperature would go above 90. As you start to shift your average temperatures a little bit higher, that means that it's that much easier to bump yourself over that 90-degree threshold. And so you start to see more and more frequent days with those very hot conditions. So what we tried to do with our killer heat analysis was to help people to see this coming so that we could potentially have a chance to make a change and steer ourselves in a different direction. So what we did is used a large set of very high resolution climate models. And we ran those models with different greenhouse gas emissions scenarios. We said, okay, how is the frequency of extreme heat going to change across the US if our carbon emissions continue rising through the end of the century? In contrast, how would the frequency of extreme heat rise if we were to very quickly and swiftly reduce our emissions and limit future global warming to about 3.5 degrees Fahrenheit or 2 degrees Celsius? And so we were able to play around with these different scenarios and look at every county in the lower 48 and ask how the frequency of extreme heat would change in those counties in the coming decades.
And we've seen some killer heat waves already, both globally and here in the United States. Not only that, but a massive increase, it seems, to when I was a kid in the frequency and severity of wildfires. Tell us a little about that.
Right. We have seen that wildfires are growing larger and more frequent in the western half of the U.S. And at least part of that trend is due to warming. Wildfires are really complex in that, it's not just temperature change that can bring on a wildfire, not just a hot summer, but we know that drought is a big player there. And we also know that the way that we've been managing our forests has made it more conducive to have these larger fires that are harder to contain. So there is some signal there in the trends we're seeing in wildfires that is related to climate change, but it's a little bit more complicated than other climate impacts like heat waves or even stronger hurricanes, because we have these compounding factors like forest management.
You make a good point, because fires are natural processes in many ways. We, with our development of cities and building in lots of places where there's brush that should burn on a regular cycle, does not. So the heat waves, what are some of I want to talk about the costs of that in a moment, but tell me about the health consequences of those.
So extreme heat can be really dangerous to our health. At a minimum, it can cause things like heat exhaustion, which most healthy people anyway, can just take some rest, rehydrate, and recover from. But the longer we're exposed to extreme heat conditions, the worse the effects are for our bodies. So at the most extreme, we can see things like heat stroke, which often requires hospitalization and can be fatal. We know that different groups of people have different susceptibilities to heat-related illnesses like heat exhaustion and heat stroke. So particularly sensitive groups would include elderly adults, young children, anyone who is taking medication that can actually interrupt your body's ability to thermoregulate. And there's a long list of those medications, many of them very commonly used.
And I'm seeing a lot more of this as a physician. I remember I've been a doctor now for 30 years, and when I got started, we'd see heat stroke or heat exhaustion on those rare days. And I was training in Southern California when the temperatures were going above 100, or we'd see them in people who had just finished a marathon. I'm seeing this here in Portland, Oregon in the summer. And it's not just the heat stroke and heat exhaustion. I'm finding that a much larger percentage of my patients that get admitted now, in addition to their underlying problem, being it pneumonia or a heart attack or you name it, also are dehydrated and have electrolyte abnormalities. And it's because of that heat and the fact that they're not balancing their intake with their output. And it's so difficult to maintain hydration. You can lose liters of water a day just through breathing, just from lung water. And you can lose multiple liters of water, of course, through your sweat. And I don't think people realize the significance of that. And you're right, it's those people who are on medications who can't hydrate who are most at risk.
Yeah, and we've seen there are studies related to that dehydration in farm workers in Florida, for example, where they've studied and monitored the health of their kidneys as they are working over a series of warm days, and they find increasing stress on kidneys over that time frame.
And they found this internationally in a number of different countries now, and there are various potential contributors to it, including pesticide exposure. A lot of the pesticides that we outlaw in the United States are made by U.S.-owned companies and sold overseas, but kidney disease among farm workers is probably predominantly related to heat. And that's the ambient temperature, of course, plus the fact that it's a backbreaking job that most people work at for many hours a day, have limited health care availability to them, and are consequently affected by this, especially in areas of the world where there's limited access to things like dialysis. And once your kidneys go, if you can't get dialysis, then you're essentially done for.
Right.
What about the economic consequences of killer heat?
So there can be many. If we just stick with farm workers for a moment, we know that many of these workers are paid either hourly or by the amount that they harvest. And so they're disincentivized to take breaks, even when it's really hot, even when they're feeling very sick. So because there would be wages lost for them, if you're making $10 an hour, losing an hour of work a day would be a substantial hit. There are also costs associated with our energy use. So 1 in 3 people in the US already have difficulty paying their energy bills, and they're already making difficult choices about whether to pay the electricity bill or whether to buy food. So if we have increased frequency of hot days in the summer, and you want to be running your air conditioning because you don't want to be dealing with heat stress, you don't want to be dealing with dehydration. You're facing those increased energy costs as well. So those are just a couple of ways that would hit us on an individual level.
Then you get hit by power outages too. And I think it's important to note that this is in many ways a subsidy from the American people to the fossil fuel industry, because we pay a lot of these healthcare related costs, the costs of having to open shelters to house people in the summer during heat waves and so on. But I'm sorry I interrupted you.
Well, that's an interesting way of thinking about it. And there's a growing movement to hold fossil fuel based companies like Exxon and Chevron accountable for their actions. Many cities like San Francisco, the state of Rhode Island, have brought lawsuits against these corporations. And the focus primarily to date has been on the fact that these coastal places will need to be adapting to sea level rise that we can attribute to the burning of fossil fuels from these corporations. So, we are, in effect, as taxpayers, all paying for climate change in these ways that you mentioned right now.
Now, this has been a wonderful discussion. In fact, we don't have a whole lot of time left. I'd like you to cover sea level rise in a couple of minutes for me, and then we'll wrap up by talking about what average citizens can do.
Great. So sea level rise is something that I studied extensively before my work on extreme heat. And I think one thing that's really interesting about sea level rise is that people hear the amount of sea level rise that we project for the next, say, 20 or 30 years, and they might think, okay, that's 8 inches or 12 inches of sea level rise. That's not a whole heck of a lot. But when we look at how sea level rise affects a landscape, if you have a totally flat beach or flat marsh area or something like that, just an inch of sea level rise vertically translates to 100 inches of inundation over the horizontal landscape. Mm-hmm. So, of course, many of our environments, they're not completely flat. So, that's just a general rule of thumb. But if you think about what that means, if we have a foot of sea level rise, that translates to about 100 feet of the landscape horizontally being affected by sea level rise. So that's about the distance between home plate and first base, just for reference. And then when we look at kind of later in this century, we're looking at somewhere in the range of 4 to 6 feet of sea level rise, which would equate to a horizontal distance of about 2 football fields. So you can see that very small amounts of change vertically have this massive effect horizontally on our land.
I think the reality is, unless some of the major cities like New York, Miami, San Francisco, Los Angeles undertake multi-trillion-dollar infrastructure projects, that in 100 years, it's quite likely that significant parts of those areas will be underwater. And that will not only displace a large number of people, but also require rebuilding of all the high rises, all the homes, everything. This is going to be really a huge multi-trillion-dollar undertaking, I imagine.
That's right. And you can look to places like Miami Beach, where they're really on the front lines of dealing with sea level rise. So Miami Beach has chronic flooding problems. They tend to get about 10 floods just on sunny days when the high tide is running a little higher than normal in an average year. And a few years ago, the city decided it was time to start addressing these flooding issues. And they've invested on the order of $500 million into increased pumping systems and drainage systems for the city. So you think about the fact that that's just to deal with the flooding problems they have today, and that's just one city's attempt to deal with them. Now multiply that by all of our coastal cities in the US. And you can see the scale of the problem.
And not many people know this, but New York subways have to actively pump out water today. So if, and this is from a wonderful book called The World Without Us, where the author imagines what would happen if people were suddenly all raptured from the planet, and he interviews geologists and chemists and biologists. And basically in New York City, if humans just left and nobody was running the pumping stations, within a day and a half, all the subways would be entirely flooded. So this is a problem right now. And certainly places like New Orleans may not even exist within the next 50 years.
Right. There will be places where we'll have to make some really hard decisions about whether we can continue living there or not.
So what, in the last minute that we've got, what can we do? What can our viewers do?
All of the research we've done has shown that making these really dramatic and near-term cuts in our greenhouse gas emissions is the most effective way to limit the damages that we'll experience in the future. So in our personal lives, we can do things like, ensuring that if you're going to go buy a new car, get the most fuel efficient one or buy an electric vehicle. There are often rebates for electric vehicles where you can offset some of the additional costs that's associated with those. But we also need to be thinking about how those efforts scale up at the national and international scales. Because really what we need is not just these individual actions, not just the actions of one town or one city or one state, but we need to see this at the global level. And so one of the most effective ways that you can ensure that we will have sound climate policy is by voting, ensuring that the candidates that you are supporting support strong climate action. You hear a lot about the Green New Deal these days, and whether or not that's a feasible plan. But the reality is, it's one of the most ambitious plans that's out there. Maybe it's not all achievable, but it's certainly the direction we need to be headed.
And we really need to have done this yesterday. So again, I'd like to encourage our viewers to watch the episode preceding this one, where we go into a little bit more detail. Unfortunately, we don't have quite as much time with Christy today. But Christy, it's just been a delight having you on the program. I encourage everyone to go to the Union of Concerned Scientists website. And I'm even going to make a pitch. I think you should donate to this group. This is a fantastic, fantastic organization that's on the forefront of using sound science to try to help our leaders develop policies to make the world a better place for us now, for our children, for our grandchildren. Christy, it's just been an honor having you on the show. We hope to have you on again sometime in the coming years. Thank you very much. I encourage our viewers also go to the Public Health and Social Justice website. My name is Martin Donohoe, and this has been Prescription for Justice. We'll see you next time.